Good morning, everyone. The topic today I'm going to deal with you is detection of adulterants in food items, both in solid food items as well as in liquid foods. Okay, we'll see how to detect the presence of adulterants in the food items like sodium, in a common salt, and then in papaya, that is papaya seeds, it is used as an adulterant in wheat flour. So both the solid food items as well as the liquid food items we are going to see today. How we are going to analyze the adulterants, okay, that the presence of adulterants in those food items in common salt and in wheat flour, and also in liquid food items like in milk, and then in vanaspati. Vanaspati it is used as an used as an adulterant in curd. So all these things we are going to see today. We will see one by one. So how to detect, how to analyze the adulterants in food items qualitatively. So first, for example, we take common salt. Common salt means it is nothing but a sodium chloride. So when sodium chloride, without salt we cannot prepare any food. So in each and every food we intake, you see, if the salt is not added, if there is absence of salt, it will not be tasted nicely. So just for it is NaCl, it is not only for it is not for adding as a taste substituent, but it is also it is good for our health. So for example, see here, chalk powder, it is added as an adulterant in common salt like sodium chloride. So the difference between the common salt and the chalk powder is, chalk powder is insoluble in water, whereas the sodium chloride, that is common salt, but that is soluble in water. So when you add the crystalline sodium chloride, when it is put in water, it easily dissolves in water, giving rise to the Na plus ions and Cl minus ions. Whereas if the chalk powder is added as an adulterant in common salt, that is insoluble in water. So that way we are able to detect the presence of the adulterant like chalk powder in common salt. So chalk powder is nothing but calcium carbonate. Next, in the case of wheat flour. In the case of wheat flour, the same adulterant that chalk powder is added. See here, the test we are going to do here is something, it's going to be a different one. That is, the sample is first treated with the dilute HCl. That is, a wheat flour, the sample to be tested, that is treated with the dilute HCl. So immediately the brisk as soon as the HCl is added to that wheat flour, brisk effervescence will be noted. Okay, so that brisk effervescence is nothing but due to the liberation of this carbonate ion CO3 2 minus ions. Okay, this due to the liberation of CO3 2 minus ions, so that indicates the presence of chalk in wheat flour. Next one is the deduction of adulterants like pepper in adulterants like papaya seeds in pepper. So when papaya seeds are mixed with the black pepper, when the sample is added with alcohol, the pure corns float. That means the pure pepper it floats on the alcoholic layer, whereas the papaya seeds never floats on the alcoholic layer. It immediately goes down. That means what? It sinks. It sinks into that alcohol. So that leads to, so when you intake or when we consume this kind of black pepper, that leads to the health disorders like a liver disorder and stomach disorder and so on. So next one is, we are going to detect the presence of adulterants in liquid food items like for example, formalin. Formalin, it is an adulterant. It is added in as adulterant in milk. See, the analytical test we do here is just we are adding, take a 10 ml of milk in a test tube, and when you add 5 ml of corn sulfuric acid through the sides of the test tube without any shaking, you will appear a blue color or violet color ring. Okay, that shows the presence of formalin. So if formalin is added, when you do this analytical test, that will tells you the presence of formalin in milk. So the purpose of adding formalin is to enhance the life of milk. It is added as an adulterant just for preservation. Next one is starch in milk. Starch. See here, in when starch, see usually that when starch, when it is when it reacts with the iodine, it forms the inclusion complex, so which appears blue in color. That same concept, that same test here also we are doing here. See here, when starch is added as an adulterant in milk, the test we do here is just to take a small drop of the milk in a slanting surface. If it is a pure milk, it leaves a white trail. Whereas if it is an adulterated milk, when you add a drop of iodine to that milk, that iodine, when it reacts with the starch, that gives you blue color. So there will be an appearance of blue color when the adulterated milk is tested with iodine. So this is one way of detecting the presence of starch in milk. The last one is the presence of vanaspati in curd. So vanaspati is also, it is added as an adulterant in curd. So here the test we do here is, the analytical test we are following here is, just you take one teaspoonful of curd in a test tube, you add HCl. That HCl, it has to be mixed thoroughly just by shaking the test tube gently after the 5th minute. So you'll see the coloration, that is red coloration appears. There will be a formation of red color in the test tube. So that indicates the presence of the vanaspati in that particular curd. So this is how we use to detect the presence of adulterants in the both in solid food items as well as in liquid food items. So hope you have followed all these analytical tests, and you'll also when you do this at home, when you are at home, you can also, when you have a doubt in the adulteration. So for example, if sodium chloride is adulterated, or if white flour is adulterated, or curd is adulterated, you can follow these tests and confirm the presence of adulterants in that particular food items. And this is one way of detecting all these adulterations in food. So thank you very much for listening to this lecture. Thank you.